So I'm Dorothy Baunach. I'm the entrepreneur in residence from the Cleveland Water Alliance, and delighted to welcome you all to the second Innovator Spotlight from the Cleveland Water Alliance, CWA, and also very excited for you to learn more about our guests today, who are taking advantage of Cleveland Water Alliance's capabilities with Internet of Things and our telemetry network that covers a good portion of the Lake Erie watershed, which I'll tell you more about in just a second. We would like to thank our sponsor, Badger Meter, who has sponsored the entire Innovator Spotlight series, and we're very grateful to them for their support. And hope that you will reach out to them if you would like to know more about Badger Meter. They're a very exciting company up in the Milwaukee area that's been inventive for more than 100 years. As mentioned, I'm Dorothy Baunach, the entrepreneur in residence for the Cleveland Water Alliance. I've been affiliated with the organization for a long time and very excited to be part of the team that talks to innovators from all over the world that have not only sensors and devices that use our IoT telemetry device, but all kinds of applications for the water industry in wastewater treatment, water purification, and industrial applications as well. Cleveland Water Alliance has been around for about 10 years, and one of our most exciting programs is our test bed. As I mentioned, this test bed covers more than 7,000 square miles of the Lake Erie watershed on the southern shore. And we test devices from all over the world, about a dozen to 20 devices annually for the last 3 years. And we have IoT devices that are put onto sondes every year, sent out to the lake. Sometimes we test in watersheds along the shore. But one of the things that we'd like to know is, are you using IoT-enabled sensing and monitoring devices in your current operation? And learn a little bit more about you and the audience that we're talking to this morning about the Internet of Things. And it looks like everyone is familiar and somewhat using the IoT-enabled devices, but not everyone. So let's move further in and see how we can help you understand and get more familiar with IoT and what it can offer in terms of sensing water quality devices. With our watershed, we are now the most connected watershed in the world with our Lake Erie sensing. And let me stop talking and get to our panelists. First, we have Ed Rudberg from Nucleic Sensing Systems, NS2. And Ed's going to talk a little bit more about his DNA sensing devices. A genetic smoke alarm for water. I love that, Ed, on your on your website, and hoping that you can tell us more. And our third question, and we'll end that poll and turn this over to Ed in just a minute. It looks like everyone is not familiar with you, Ed. So with that, let us have you tell people more about NS2 and what you've been doing to help detect organisms in water.
Well, thanks so much, Dorothy. I really appreciate the introduction. As Dorothy noted, my name is Ed Rudberg. I'm the CEO of Nucleic Sensing Systems, and we're developing the world's first autonomous and continuous biosensor for the detection of what's called environmental DNA. And many of you all are probably familiar with environmental DNA, but every species alive, from viruses to whales, sheds DNA into the environment. I'm sure many of us know that the dust in our home is largely made of skin cells. And what we are developing is a technology that can autonomously and continuously detect that DNA that's left in the environment. As a society, we are facing environmental and health catastrophes and really economic hardships without the real-time detection and ongoing monitoring of biological species of concern. We do a really good job at measuring physical and chemical parameters in waters or otherwise, whether that's temperature, dissolved oxygen, pH, etc. There's a bunch of IoT sensors for that. But where we really are lacking is in that biology sensing, that IoT sensing around biology, whether it's in our natural resources and oceans, where invasive species cost the world's economy in excess of $400 billion per year, or in animal health, where disease costs aquaculture producers in excess of, in excess of $5 billion per year. Or in water and wastewater, we have a lot of concerns over Legionella disease, and wastewater treatment we know is notoriously inefficient. But even in biomanufacturing, where we create little ecosystems in vessels, those are inherently inefficient processes and really put that industry at risk. We can go to the next slide. So what we are creating is what we're calling the tracker. It's a device that what we've done is essentially taken a human health diagnostic tool and taken it into a box and put it into the field. I know we've all remembered times in which we were swabbing our noses for COVID, right? And you either had COVID or you don't. What our technology uses is a technology called droplet digital PCR. So what we're essentially doing is swabbing the environment's nose, if you will, 20,000 times in a single sample. So what we get are a bunch of ones and zeros that come out. Either it had the DNA in the subsample or it didn't. And what that allows us to do is quantify environmental DNA in the field. And we can show, most importantly, changes over time. And we can do so without a human. It's kind of the set it and forget it, if you will, of biological monitoring. And right now, we can detect up to 3 species at the same time. And our goal is to automate processes, particularly like wastewater, biomanufacturing, or aquaculture, so that they can use our technology and our data that we develop to drive automation via machine learning and AI. And go to the next slide. So when we look at the target molecule that we look at, there's a few different types of what we call environmental DNA, and there's what is typically looked for. Many of you all probably have done environmental DNA sampling. You take a large water sample, you dip it in the water, put it through a filter, and what comes out is what is tested. It's cell-associated DNA. It's the cells that stick to that filter. And that's really because it's easily stabilized. And as we move forward, there's also particle associated. So a cell lyses in the field and in water, and the DNA sticks to particulates. And that is also the type of DNA that's often sampled. But we're looking at something totally different. It's called free environmental DNA or an RNA. And why it's not usually looked at is because it's super short-lived. So cells typically lyse in the environment, that DNA comes out and it gets chewed up by bacteria because it ends up becoming food. And what that allows us to do is take out a couple of the steps and really automate the process by not needing to lyse the sample, but it also can show us that an organism was most likely alive, or we can look at RNA, which means it was making protein still, or even viruses. And that's really what we're looking at. We can go to the next slide. So here's an example of the type of data that we can collect. So this is in Lake Mead, working with the National Park Service. Starting at Site 1, nearshore environment, many of you all are familiar with quagga and zebra mussels. They like to attach to rocks and surfaces. And so near the shore, you would expect there to be a high concentration of environmental DNA for quagga and zebra mussels. But as you get towards the middle of the reservoir, you see that precipitously drop and be less concentrated. But then as you come into the marina, where you have docks and boats and all these types of things that zebra mussels can live on, you see a much higher concentration of quagga and zebra mussel DNA. And go on to the next slide. You can also take that data and it looks like this. So rather than that typical, hey, we're looking for environmental DNA, it either has the species we're looking for, it doesn't. What's really important about environmental DNA and digital droplet PCR is that it is really robust against what we call inhibition, which means, oh, you got dirty water, it's tough to detect the environmental DNA. Or in this case, you might have gasoline, one of the big inhibitors for looking for an environmental DNA. And so what we're looking at here is how brightly those tiny little droplets glow to show that you do indeed have environmental DNA there. And you can see there's a wide range, right? There's the ones that are very tall in green and the ones that are much shorter. But because of just the inherent technology with droplet digital PCR, we're able to set what is a positive and what is a negative. So we can really delineate and make sure that we are quantifying that environmental DNA correctly. And what you're seeing here is before decontamination at a recreational vessel getting sprayed down with hot water decontamination. And then you see the water coming off of it afterwards. So we're not only showing the efficacy of decontamination efforts, but also our ability to differentiate those positives and negatives in a very dirty, if you will, environment. And we can go on to the next slide. The other great thing about droplet digital PCR and why it's so great for environmental DNA is to that needle in a haystack. Droplet digital PCR is great for finding very small amounts of environmental DNA in the field. And for those that work with environmental DNA, you really understand that often what you're looking for is a protected species or you name it. It's just not a highly occurring molecule. But what we're finding specifically with the free environmental DNA is within 20 microliter sample, we're finding the concentration of free environmental DNA akin to cell-associated or particle-associated in 5 liters of water. So 20 microliters having a representative sample of 5 liters. So really big difference there in just the abundance of that molecule. The other thing we can do is show changes in the amount of biology over time. So this is an example of some data that we've collected from Pacific Seafood. They were interested in columnaris disease, very common in the water column when you're looking at salmonid aquaculture. And they're not worried about positives and negatives. And the reason being is columnaris disease is omnipresent. So if we would look and typically say, hey, yep, 1 or 0, it's there or it's not, that's not very valuable to that customer. And to many customers looking for something that's always there, they're far more interested in a change in that genetic concentration over time. So this is another way of showing the data called histogram, which I'm sure many of you all are familiar with, where we see the positives on the right, the negatives on the left, and then we can take those samples as often as every 15 minutes. So if there was a sample of concern, everybody knows, with your phone, how you can do fast photos, right? You hold down and it takes a bunch of pictures at the same time. That's essentially what we can do. So testing every 15 minutes to have that confirmatory analysis with that you need, including onboard positive and negative controls. So with that, Dorothy, that's a pretty good, background on our technology and what we're doing. I think I'll turn it back over to you and Chris.
Thanks so much, Ed. That was interesting and very exciting and takes me back to my biology days. So let's turn to Chris, who is the CEO of AquaRealTime. Chris also has a tracker, the algae tracker device. And his focus is a little bit different with harmful algal blooms. And we know that we have harmful algal blooms that plague Lake Erie and many lakes around the country and small bodies of water. So, Chris, let's turn to you and see what you're doing with your tracker.
All right, thank you, Dorothy. My name is Chris, and I'm the co-founder and CEO at AquaRealTime. Next slide. So many of you are probably familiar with multi-parameter sonde systems. These are systems where you have multiple probes like pH, DO, chlorophyll that you plug into a sonde, and then you can assemble that into a larger buoy system. You could get solar panels and a telemetry system added into there. and create a floating buoy that would monitor a lot of different parameters. So what we've developed 5 or 6 years ago is a system that's all in one. It's a complete system. You just take it out of the box. It is a buoy that tracks a lot of different parameters, but doesn't require any assembly. It already includes the cellular and all this other stuff. So just taking a 30,000-foot view, of course, I think everyone knows the benefits of monitoring for algae or other water quality parameters. We're not just focused on algae. Pretty much anything that drinking water and many of the things that wastewater and recreational areas look at, we do, is to first of all, detect problems early as possible, not detect them within a week or two, detect them right as they're happening so that you can time the public warnings or do treatments or take other measures. In a lot of cases, people are limited with the amount of staff they can have. So this allows them to cover a lot more territory, have full lake or reservoir visibility at a fraction of the cost of either sampling or some of these larger buoy systems. And if treatments are done, you can see whether or not they're working and prove that to important stakeholders. Next slide, please. So a little bit of detail on what our algae tracker by default measures. So what you're seeing here on the right is the standard configuration without any added sensors, and that will measure the chlorophyll A for any kind of algae, the phycocyanin that's targeted to cyanobacteria or the potentially toxic algae, turbidity, water temperature, of course, solar light, because that'll affect the growth of organisms. And then the GPS location is always live. We can add on sensors for pH, dissolved oxygen, conductivity, and newly dissolved organic matter, UV245, and ORP. As part of our very expansive dashboard, we also pull in air temperature, precipitation, wind direction, and speed, so you have a big picture of what's going on. Measurements are taken every 30 minutes, and they are uploaded to the dashboard automatically every 2 hours. Next slide, please. So a little closer up on how the thing works. We do have a solar panel on top, so that recharges an internal rechargeable battery. So even if this device was without sun for up to 2 or 3 weeks, it would still be able to take its measurements and proceed. But with the solar panel, we're able to leave these out pretty much year round if there's no ice. The limitation is if you're in a place where you're getting ice, you're probably going to have to take it out in the winter. The big differentiators between our system and other SON systems is that this one is completely turnkey. You take it out of the box, press the power button, and within 5 minutes, you're getting readings on your cell phone, any device. You don't have to set up cellular or power or anything like that. The installation takes less than 15 minutes compared to potentially several people a day or two for some of the larger buoy systems. Because it's a more cost-effective solution, you can get full lake visibility. People are typically putting out 3 to 5 of these units rather than just one and not knowing where to put it. You can have basically a lot of different locations. You can see on the bottom right the anti-fouling brush system that's there. That's a picture of the device upside down floating in the water. You can see a lot of biofouling will develop on the device, but that window, which is the top part that gets brushed, that will stay very clean in long-term deployments. And that's the key to having a long-term low maintenance device, is to have low biofouling and not have drift in those sensors. So we do the brushing before each and every measurement, every 30 minutes, 48 times a day, and that does a really good job. Next slide, please. The other big differentiator for us is the dashboard. So this is automatically included in the system. Our dashboard is by and large considered the best one of the competitors in this particular space. You have a live GPS map showing all your different devices with highlights of each one on the map. Email alerts at any action thresholds that you can define. Of course, historical charts over any time frame up to a year, even two. Color-coded gauges that you can set the color of depending on the severity of the issue. They'll automatically switch from one mode regime to the other and then send you an email alert. And we have a lot of quality control data tools. So you can manipulate the data. You can remove spikes in environmental data. You typically get that. You can download the data anytime. And we also have something called self-health diagnostics. So if there isn't a problem with the device, you won't get any messages and you won't need to go do maintenance. But when there is a problem, we'll send you an email, and then that's when you would do your maintenance. We also have what's called an API integration. So for those who have a complex or an advanced software system that they use and they want to pull the data into that, whether that's a lake association that has their own website, or if it's a drinking water utility that has their own software, you can pull that data in directly. Next slide, please. So this is some accuracy testing done by an independent third-party lab. The x-axis is the exact true extracted data for both chlorophyll and phycocyanin, and the y-axis is our sensor measurement. So a perfect sensor would be a perfectly straight line with an R-squared of 1.0, and you can see we're at 0.99 and with a very straight line. This is for live cyanobacteria, by the way, as opposed to a synthetic rhodamine solution where you can get more nines on that R-squared value. But now, when you put this into a lake or a reservoir, there will be a degradation in the accuracy, but you'll still get a very good trend line showing what's going on over time. Next slide. As far as installation, as I mentioned, it's a pretty quick installation. We provide what's called a rigging package. You can see here on the bottom right, there's a red ball buoy and then stainless steel cabling. So we provide everything up until the anchor itself. So you would need to provide any kind of fixed object, but basically, other than that, everything is taken care of. Just need to make sure you have a water depth of at least about 2 feet and to get sunlight for part of the day. Next slide, please. So I won't be able to go into the dashboard too much, but happy to go into a demo with any people who are interested at a later date. Next slide, please. As far as what the maintenance is, like I said before, we have self-health diagnostics. We also have something, a weekly summary report email. So that's where you get a list of your devices, a list of various parameters. Did your chlorophyll values go higher than your alerts? Was there any downtime of the device? That kind of thing. We have something called a preventive maintenance package, and most people opt for that. That's included in some of our plans where you can send the device back at the end of each year. And rather than have to do calibrations yourself and maintenance, we do a complete refurbishing of the device. We recalibrate, clean it, open it up, take out, and replace any parts that need it, that kind of thing. Other than that, people are doing visits to do basic maintenance as often as 1 month if their assets are really critical. But some people will basically go the whole season or even 6 months. We have various ways of calibrating the data, believe it or not, remotely, so you can get reset points where you calibrate to samples. Next slide, please. Actually, that's pretty much it. I was going to do a case study, but I knew that there was going to not be enough time, so I passed on to this one. So thank you, Dorothy.
That's awesome, Chris. Thanks so much. And thanks to both of you for giving us this overview. Now, we do want this to be an interactive session, and we've left enough time for questions. Please use the question and answer function on your screen to ask some questions. And while the audience is doing that, I have a couple of questions that I'll start off with here. So one thing for Chris before you mute, you've recently used the test bed, the Clean Water Alliance test bed that I've mentioned at the beginning. I think you've deployed for 2 years. And could you tell us a little bit about that experience and what you learned and how your device was we helped to validate that device for you? Would you mind
Yeah,
elaborating
absolutely.
on that?
So it was placed in various locations in Lake Erie and Sandusky Bay and at a bridge somewhere east of there. And yes, a couple of years. So it was it was very good. Lake Erie can be a pretty challenging environment, both from the aspect of waves and stormy weather, as well as biofouling. You can get a little bit more there than in some cleaner lakes. Not saying that Lake Erie is dirty or anything, but there are some challenges. So yeah, we at the time of those deployments, that coincided. We made some improvements to the tracker, partly due to that. So one thing that we did is we added the rigging packages, so that in the past, the rigging was kind of left up to the customers, and that made it challenging because you could easily make mistakes with how it's connected. So now we've replaced everything with large marine grade shackles and stainless steel cabling and this extra ball buoy that makes it more visible in these locations. And basically, you just need to have that fixed asset that you connect it to. We've also added what's called the protective dome. So in the past, the device could flip over and stay upside down, and you'll be measuring air, which is obviously not a desirable thing. So we now have a dome version. Well, it's all of our trackers are now domed, so they cannot stay upside down. We've also made improvements on all the connectors and basically ruggedizing even more than it was before. And last, we have a satellite version coming up here. We have what's called the Tracker XT. So this is a version that will have satellite communications. You can put it anywhere in the world, including the middle of the ocean. Absolutely no connectors on the outside, so there's no way for it to have any kind of issues with bouncing off things. Basically, an even more ruggedized version and that was developed with funding from NOAA in a grant. So yeah, a lot of benefits from the test bed and improvements to the platform as a result.
Yes, we know Lake Erie can be challenging. If you're familiar with Lake Erie, it's the shallowest of the Great Lakes, and those waves and storms can kick up pretty quickly. And we do have significant algae blooms in the lake that, given the number of people that rely on Lake Erie as a water source, are very troubling in the summertime. And so this detection is very important. I'm going to come back to you, Chris, a little bit on maybe the interventions, but I want to go to Ed because one question, actually I have two questions for you, Ed, and there's a few questions coming in online now too. So my question to you is, how do you display your data, and is there a data function where you're collecting this data to present to the customer when that's ready? And the second I'll save till after you answered that.
Yeah, absolutely. Thanks, Dorothy, about asking about data. Exact same thing. We're pushing to a data platform. We want to make it as easy as for our customers as possible, so they don't have to connect to the machine or anything else. And we're connecting, can connect Bluetooth, Wi-Fi, satellite. We're really agnostic when it comes to how you connect to the data. So it's really what's cheapest, best, and fastest for our customer so that it can get to that data platform as easily as possible.
Yeah, and given what you're measuring, it's really important that you can actually get that in real time, continuous measurement, because as you've said before, that data usually had to be collected, or the samples had to be collected, taken to a lab, and it would take days to get that information. And in days, when you're talking about microorganisms infecting water with whatever's coming along these days, it's just easy and better to know it faster rather than slower. And the fact that you can get so precise on those microorganisms with the DNA analysis and RNA analysis is really exciting. So the other question, this is a bit of a setup as well, but you've just been accepted into the generator cohort for the current Great Lakes Accelerator program. So please give us some information on that and how you think it's going to help you.
Yeah, absolutely. The team at Generators has been fantastic. It's a group that I've been in touch with for actually a couple of years, and finally found the right match at the right time for us. And the team is great, and they're always, willing and excited to make introductions and help you through the process. But we're midstream on what we're calling, or what they call, a mentor swarm. So for 3 weeks straight, for 3 days a week, we are having essentially like round robin dating, if you will, where you have conversations with stakeholders, with potential venture capital firms, with so many different people in the water space in the Great Lakes. So I think when it's all said and done, we'll have over 100 conversations. And so if you are interested in the Great Lakes, if you have a technology that can be deployed in the Great Lakes, or help the Great Lakes region, they are having additional cohorts as they move through fall in the coming years. I would highly recommend to anyone that is interested in the Great Lakes, that's interested in doing business in the Great Lakes, and can have positive impacts on the Great Lakes region, particularly when it comes to water itself. I would highly recommend putting in an application.
Thanks so much, Ed. And yes, and thank you to Generator for putting this together. And CWA is in partnership with the Generator team on this particular accelerator program. And we're very excited because we know that conversations with customers and those that are interfacing with water every day and their needs are really important for entrepreneurs. So we welcome the work that it takes by Generator and a company like NSC2 to participate in these and take full advantage. Chris, just one last question. Nope, not for you. Here's one for both of you. And this is from the audience. So do the sensors support LoRaWAN wireless connectivity? And I think maybe that came in for Chris, because this was while you were talking, Chris. So do your sensors to support the LoRaWAN wireless connectivity? And I'll let you answer that.
Yeah, so we're using a platform that allows us to switch between Wi-Fi, cellular, LoRaWAN, and satellite. All of our devices so far that we've sold have been using the cellular platform, but switching to the LoRaWAN is something that is, we're just kind of waiting for the right moment to do it, because we have the capability of doing that switch. Again, the platform supports it. We just haven't sold them in that format yet. So short answer is it can be done quite doably, but it hasn't actually been done to date.
Dorothy, I'm happy to answer that question as well. It looks like it was for both. No, we're agnostic when it comes to how we push our data to the cloud. So yeah, absolutely can you use the wireless connectivity, Bluetooth, or satellite, or otherwise. We realize that many of our customers won't have easy Wi-Fi connection. Some of them will, but many of them, will be satellite or otherwise. So we need to make sure that we can connect and get our technology to work with wherever the customer's needs are, as when it comes to that connectivity.
Well, then, CWA's network in Lake Erie is primarily a LoRaWAN network, but Chris, we were able to accommodate that, and we can also switch off to cellular, but it's really designed as a LoRaWAN network. So
yeah, no, LoRaWAN really makes sense in Lake Erie, specifically LoRaWAN, because you may have a lot in a similar location, and the stakeholders may be a lot of overlap between the stakeholders. So having one system with a bunch of gateways for LoRaWAN is definitely a good way to go.
that's awesome. Maybe, and I don't see any more questions. It looks like one more is coming in, but I was going to ask Ed, what other species are you looking to be able to identify, and what's the next step for development to make sure that you're covering this infinite number of microorganisms that we're seeing, but to really tag those most important ones?
Yeah, so historically, this technology was originally invented at the University of Montana for quagga and zebra mussels. So that's a lot of the work that we had started with. But we realized as we commercialized the technology out of the laboratory that there were a lot of other options right now. We're working with NOAA on an SBIR3 project and the US Navy that's looking for bottlenose dolphin and human waste indicators. So there's a lot of opportunity out there, but where we're really looking for, hoping to have some pilots in the near future this fall, water and wastewater, whether it's Legionella disease or you name it, looking for bugs you want in wastewater or bugs that you don't want for making these systems more efficient, because we're totally agnostic when it comes to the type of environmental DNA or RNA that we're looking for. We just need to make sure there's either primers and probes that are available and the commercial sites, IDT or otherwise, or if there is not, going to the literature, scientific literature, and finding those unique genetic sequences to have a primer and probe made.
Very good, thank you. Yes, the possibilities are exciting, and it never occurred to me back in the day when DNA and RNA PCR was introduced for the detection that we would be seeing those uses in water as well as in humans. So it's exciting to see the evolution of that technology. Chris, I think this question is for you, but maybe for Ed as well. But you mentioned the use of satellite as a way to collect the data, and there was a question about power consumption with satellite data. You want to elaborate on that a little?
Yeah. So in the past, when people were using satellite data, it was usually through a system called Iridium. And there was a timing issue. You didn't know if you had the satellite above you, and maybe you had to wait. And that's a power problem because you can't go to sleep. Nowadays, we've got way more satellites, and the new systems that are right now, like in the last year and for the next 2 years, there's a big move to something called direct to cellular. So basically, it's sort of overlapping satellite and cellular systems. And basically, the bottom line is that there are effectively way more satellites to talk to. So the communication wait time is not there, not nearly as bad. So power should not be nearly as much of an issue as it was before. And in our case, the size of our solar panel is 5 watts. It's overpowered. So we have more charging ability than we need now. So we have the ability to go quite a bit, use more energy than we are using already. The other thing is, if there does become a challenge, our system will automatically adjust. So let's say if we're pushing data every 2 hours, we see that the battery strength is coming down to 60% instead of 85, where it likes to stay. Then we simply we automatically reduce it to 4 hours or 8 hours. So we can adaptively adjust. That helps for northern climates and for situations where there's different weather patterns, or as we deploy things that may use a slightly larger amount of power.
That's awesome, thank you. We know the Clean Water Alliance is focused on Lake Erie and the Great Lakes, but outside of the Great Lakes region, where are you both using your tech, both in the US or internationally? And Chris, since you're unmuted now, I'll go to you and then Ed follow with you.
So we have trackers all over the US. I think definitely most states at this point. A lot of them in, I mean, it's really spread out. So certainly Florida, Colorado, California, New York, Massachusetts, a lot of places, Michigan, So then a lot in Canada as well. We're seeing a lot of market pull in the Maritimes. In Canada, they're a bit earlier the government has released a document saying, here's what we think the levels for chlorophyll and phycocyanin, maybe not phycocyanin, but at least chlorophyll should be for these different types of waterways. So there's more guidance, and both lake associations, recreational areas, and drinking water utilities are turning to those government guidelines to try to implement and at least set up their monitoring ahead of time so that if treatment has to happen, they're ready. We also are selling in Europe to some extent. So Israel, we have quite a few units in Israel. Germany, we haven't really pushed the Europe sales very much at all. It's just been what kind of has come in. We don't market out there or anything like that. Australia, we're starting in as well. We definitely are looking to branch out more into the Southern Hemisphere. So.
Go ahead, Ed. Thanks.
Sure, thanks, Dorothy. And we've been federally funded to date, so our focus has largely been in the United States, as we've still been very much in pilot mode and pre-commercialization. But we know moving forward that with the wastewater issues that they're seeing in Europe with aging infrastructure, that's going to be a real priority for us as we move forward. But so far, at least, have been US focused.
That's great. And then one other question before I go to one from the Q&A. Chris, what are you seeing in terms of interventions for harmful algal blooms? So detection is one side of the story, and we see this across all kinds of lakes, inland and whatever. If you're golfers, you're going to see the algae on the golf course, and once it's there, particularly if you get to that cyanobacteria, we're in trouble. The more we see, the more trouble we're in. But what about the intervention for?
Yeah, that's a great question, and it's the key point really. What are we doing about it when we have this issue? So I mean, I think most people are familiar with the old hammer that was used on most nails, which is the copper sulfates and those algicides. And by all means, more and more water utilities are actually using those when they didn't 3 years ago, because the problems have really gotten worse. But the good news is, and I'm not really knocking, there's definitely a place for that kind of heavy hammer. But things tend to recur more quickly when you use that type of tool. We're seeing people turn to encapsulated technologies, encapsulated hydrogen peroxides and other precursors to hydrogen peroxide. There's a variety of companies, and I'm not, sort of trying to sell any companies here, but Blue Green Water Tech has a more environmentally friendly and more long-lasting solution that incorporates the monitoring. We're working with several companies that are doing nanobubbles. Again, you can have a more environmentally friendly method of treating and more of a constant flow using either pure oxygen, which is debatable on when and where it's useful, but you can also put other gases in, such as microdoses of ozone, that can be very effective and be quite healthy, and it disappears very quickly. So there's a lot of research and a lot of good stuff coming out in the treatment general area. There's also sonic waves, ultrasonic waves, and that they have their place too. And other things are coming out too. So there's a lot of good stuff coming.
That's great. Yeah. And, with the couple hundred innovators that we talk to a year, we're seeing a lot more intervention technologies on the algal blooms. And, maybe we'll even do a spotlight on those one of these days.
Yeah, you definitely should. I mean, there's a lot of interesting stuff there.
Yeah, and you've mentioned many of them. So, looking for ways to not have to add so many chemicals to the water, because it just complicates the issue more for the organic species that we need and want there. And then Ed, how about you? What are you seeing on the intervention side on some of these other bacteria that we don't want, or viruses that we don't want there?
Yeah, absolutely. And to Chris's point is we're seeing, I mean, for us, because we go across many different verticals and we're addressing many different items, in wastewater, for example, aeration. And our goal is to optimize when that aeration occurs, micro bubbles. So there's a lot of really interesting companies that are coming out right now with nanobubble technology. If we're looking at aquaculture, what our goal is to really reduce the amount of antibiotics being used or otherwise. So you can do things like harvest at the right time. If you can change feeding cycles, the goal is really to reduce environmental impact, energy cost, and optimize these systems through our quantitative measurements. And we always say we don't make the Tylenol, right, that takes your kid's fever down. We just tell that, hey, your kid has a fever. And so we find ourselves partnering with solution partners to bring together a solution suite for a customer because they have a problem. We need to come together and bring them that solution suite.
That's a great approach, which is one that we all need to be mindful of. Chris, I'm going to come back to you because this is a question from online. Can you discuss a little bit more the challenges that you've faced in optimizing the strategy for the biofouling that you've experienced? And
Yeah. So, most companies who do sondes and monitoring buoys have some sort of brushing system. And by and large, and I'll just brag a little bit here, we've been told numerous times that people believe ours is the best. There's another company that does a good job at it, YSI, but there's how you do the brushing really matters, and also what you're brushing matters. So we have a extremely finely polished glass, very hard glass that's much easier to clean, and our surfaces are kind of engineered to be very easy to clean. The brushing frequency, of course, that plays a role. And we also have the ability to detect if there's anything that might be catching on the system. So we can trigger remotely and automatically or on demand a deep clean. So we can do, rather than have the standard brushing, we may do like 20 cycles in one direction and 20 cycles in the other direction. Again, our system is overpowered battery and solar power wise, so we have the ability to do those extra cleaning. So we've had very good success with the biofouling standpoint, and I'm very happy about that.
that's exciting. And it's not the only device that we see that has biofouling issues, and there are many creative ways to do it. But I think you're right on the brushing, and some of these biofouling, whatever these organisms are pretty nasty, and they can.
Yeah, I guess. Sorry, let me just say one more thing. I think maybe the question may have also been addressing what if you have not just algae, microalgae, but what if you have barnacles and larger things like with shells? And that's something I didn't just address. So yes, that is a separate issue where you need to have basically a copper. You need to have copper on the bottom. And so on our current instance, the algae tracker, we have the ability to we have the algae tracker copper edition, which is a fully taped copper bottom. Does a great job. It does have to be the tape does have to be refreshed at the end of the year. The new Tracker XT version that we have is going to be electroplatable, meaning so we'll have an option where we will do this. It's not like the customer would do this, but we'll have an copper electroplated bottom. And other aspects of that system will also make it even more anti-fouling ready.
Thank you. So I'm going to switch it up just a little bit here as we come to the end of time, but not the end of time literally, just the end of our time together this morning. So Ed, please, you're both in a developmental stage, and you've been working hard on this technology to perfect it, to get it right, to test it, to see where it's going to go. What market challenges are you facing at this point? And tell us a little bit about that.
Sure, absolutely. I mean, I think we're all facing tariffs and an uncertain marketplace. I mean, whenever you have an uncertain economy that has implications, whether it's on the venture capital side, on the procurement of parts side, any of that, I think is challenging. I think also the austerity we're seeing in the federal government when it comes to NOAA and the trickle down to potentially with the ocean observing systems that we have throughout the country. I think that definitely is takes an impact on environmental monitoring, and so I think those are big things that we're all dealing with universally in this space. And my hope is that, at least for us, we can continue to look at B2B and different contexts and different verticals. And so that's part of the reason we're trying to learn a lot more about water and wastewater and even data centers and their issues with biofouling. So I think we're all having to be a little bit more creative in the type of markets that we pursue.
Yeah, and just real quickly, so what verticals do you feel you're going to address first, and what's your competitive advantage in that very first one that you think you're going to go after for your sales?
Yeah, absolutely. So I see us going at both aquaculture and wastewater, thinking about Legionella disease, particularly in Europe, and aquaculture simply because we've had a lot of traction there from pilots and otherwise, and that's where we were originally supported. And so we see aquaculture growing not only internationally, but in the Great Lakes as well. And so our ability to track disease, any concerns that we would have with those production facilities, and any of the disease or other organisms that might be problematic.
That's awesome. Thank you. And Chris, the same question to you.
Yeah, for market challenges, well, first I'll echo what Ed said. I think it's when prospective users of monitoring technologies are faced with a government that's removing spending for anything to do with environment and water, it's not the right environment to promote our industry, that's for sure. And certainly tariffs. I won't go into that. It's a little too much for this call. But I think on a negating that stuff, and you've potentially talked about this in previous calls. Educating customers on how can you change your process to help to use tracking devices that are continuous and real time. How does that benefit? So what we've started doing is on a monthly basis, we are doing case studies and interviews with existing customers where they talk about what exactly they had a problem with, what they're using it for, how this helped, if it helped. And we've been putting those into the website. So we've had case studies for every month for the last 6 months or so, with interviews from drinking water utilities, lake association, lake management companies, and others. So I think that's been really good to sort of educate people on, okay, what would I do? How would this benefit me really to use this? So yeah, that's I think really having a better communication with how this can benefit.
Yeah, thank you. And, just to those on the webinar, both of these companies have mentioned NOAA and how important that's been and how important it is to further the development. So I hope you all remember NOAA as you speak with your elected officials about what's really important for not only the Great Lakes, but all freshwater water sources so that we can help to keep them clean and safe as we all depend on it. We're about ready to wrap up here. And Ed, let me start with you. Anything further that you'd like to say to those in attendance this morning and to wrap up a little bit on your thoughts from NS2's perspective?
Sure. Thanks so much, Dorothy. I really appreciate the opportunity. Right now, we're still very much in customer exploration. So if those that are interested, love to pick your brains if you're in water, wastewater, or otherwise in the water industry, just to learn more about the issues you're facing from a biology perspective, what type of biological monitoring you do now. Just trying to learn, continue to learn more about customer pain points, and love to have those conversations. So please do reach out to me.
Thank you. And Chris, wrap up. please.
Yeah, thanks so much for having us. Thanks to the CWA for hosting these, and Badger Meter for supporting as well. We are happy to talk to anybody, get on a call, give live demos. We have a demo dashboard if people want to look at how that works, and happy to get on calls with anybody who has any questions.
Thanks to both of you. I'm so happy that you were both available this morning to talk about your technologies, Ed and Chris. I'll add my thanks to Badger Meter for supporting the series, and also thanks to all of you for attending on this morning after the holiday, and we really appreciate you all taking the time to be with us for this Innovator series. And please register when you can for our next one, which is on June 24th at 10 a.m. It's going to talk a little bit about rapid detection, and we can talk to you all then. Have a great morning and great rest of your day. Thank you.